Hi everyone, welcome to my channel Edu-spectra. So in our previous class we have completed our exercise number 1.5. So now today we will be starting with a new topic which is laws of exponents. Okay, so this is something you have been learning from your lower classes. So let's see, laws of exponents. So you know what are exponents. Exponents are something which consists of a base and a power. You are raising the base to a particular power. So if I tell you the example of 2 cube. So here we can say 2 is the base and 3 is called the power of this 2. Okay, another name that we call for power is index. Okay, if you want you can note it down. So when I say 2 cube, what is the meaning of 2 cube? I have to multiply it 3 times. So 2 into 2 into 2, we know it is 8. So 2 cube means 8. Okay, this is the meaning of exponent. We are raising a base to a particular power. Okay, now here there are a few important identities or a few important formulas that you have to note it down. Okay, few of them you have already learned in your class 8. Okay, so let's see. The first one is a raised to m into a raised to n is equal to a raised to m plus n. Okay, that is your first one. For example, if I give you an example, 2 raised to 5 into 2 raised to 2. Okay, so how will you write this? A raised to m into a raised to n is equal to 2 raised to m plus n. So we know 2 raised 5 plus 2 is what? 2 raised to 7. Okay, so this is the way in which we should write it. So 2 raised to 5 into 2 raised to 2 means 2 raised to 5 plus 2, which is 2 raised to 7. Okay. Now our second identity is a raised to m divided by a raised to n is equal to a raised to m minus n. When we do multiplication, we have to add. When we divide it, we have to subtract. Okay. For example, if I say 2 raised to 5 divided by 2 raised to 4. Okay. A raised to m divided by a raised to n is equal to a raised to m minus n. So this is equal to 2 raised to 5 minus 4. So we know what is 5 minus 4? 1. And we know 2 raised to 1 it is 2 itself. Okay. So we got our answer as 2. So basically when we are multiplying, we have to add it, and when we are dividing something, we have to subtract it. Okay, I hope I am clear with this. Okay, that is our second identity. Now our third identity is a raised to n, the whole raised to n is equal to a raised to mn. Okay, a raised to m in the whole raised to n is equal to a raised to m into n. Okay, so if I say 2 raised to 2, the whole raised to, let's say, 3. Okay, so how will you write this? 2 raised to m, the whole raised to n is equal to 2 raised to m into n. That means we have to multiply this 2 and this 3. So I can write 2 raised to 2 into 3, which is equal to 2 raised to 6. Okay, I hope I am clear. If I say 2 raised to 2 the whole square again. So how will you do? 2 raised to 2 into 2, which is 2 raised to 2 into 2, which is 2 raised to 4. Okay, I hope I am clear. That is a raised to m, the whole raised to n is equal to a raised to m into n. Okay, we can multiply these powers and write the answer. Okay, I hope it is clear. Fourth one is a raised to m into b raised to m is equal to a into b the whole raised to m. So here just see the difference between this and this is that now here the bases are different but the powers are same. And here the bases were same, the powers were different. Okay, so if I write one, I will give you an example. For example, I will say 2 raised to 3 into 3 raised to 3. Okay, 2 raised to 3 into 3 raised to 3. How can we write it? These two, the bases should be multiplied while the powers remain same. That is 2 into 3 the whole raised to cube. We know 2 into 3 is what? 6. So our answer will be 6 cube. Okay, I hope I am clear. If the powers are same, we can always multiply the base and rate. Okay, this is our fourth identity. A raised to m into b raised to m is equal to ab raised to n. Okay, I hope I am clear. All these four identities you have learned in your lower classes. Now just see the fifth one. Okay, for example, if I write 1 by 3 square. Okay, if I write 1 by 3 square. Now if I want to bring this 3 square to the numerator. Now this 3 square is in the denominator. I wanted to bring it into the numerator. So when I bring this 3 square to the numerator, that 3 will remain as it is, while this 2 when it goes to the numerator, this becomes negative. Okay, so I will get the answer as 3 raised to minus 2. So whenever you are bringing something in the denominator to the numerator, the base remains same but the power gets a negative sign. Okay, otherwise also if I say 1 by 3 raised to minus 5, if there is a minus 5 in the denominator, when I bring it to the upper side, what will I get the answer as? 3 raised to 5. Okay, so you should remember whenever something in the denominator goes to the numerator, the base remains the same but the power sign changes. If it is positive, it becomes negative. If it is negative, it becomes positive. Okay, that is something which you have to keep in your mind. Okay, so that is your fifth identity. Now, our sixth identity is a raised to 1 by n is equal to nth root of a. Okay, this is over here. If I say 2 raised to 1 by 2. Okay, this is a fraction over here. They are telling that we can write the same thing as nth root of a. Here what is n over here? Here n is this 2. So I can write this 2 over here. A is what? This 2. And we know square root of 2 is simply 2 itself. Which means we know square root of 2 is an imperfect cert. So you should be knowing that we can write this square root of 2 also as 2 raised to 1 by 2. I hope it is clear. That is a raised to 1 by n is equal to nth root of a. Okay, now if I say, if I give you another example, a raised to 1 by 3. Okay, how can I write this one as in the root form? How can I write this fraction in the root form? I will put my root over here. Here n is 3, so that I will write over here, and our base is 8. So I will get my answer as cube root of 8. So we know what is cube root of 8. Cube root of 8 is 2. Because 2 into 2 into 2, we get our answer as 8. Okay, this is the way in which we can bring a raised to a fraction form into the third form. Okay, I hope it is clear. Now our next identity is a raised to m by n is equal to nth root of a the whole raised to n. Okay, so for we will take an example for this one, seventh one, 32 raised to 2 by 5. Now in a previous one, for it was like 2 raised to 1 by 2. The numerator was same. Okay, the numerator was only 1. Now here we are having a particular value for both numerator and denominator. So how will you write this? This can be written as whatever is in the denominator, just write it over here. That is fifth root of this base, write as it is 32, and whatever is in the numerator, it will come to the whole of the power, that is fifth root of 32 the whole square. Okay, this is the way in which we can write this thing. Okay, so a raised to n by n is equal to nth root of a raised to the whole raised to the n. Okay, so this is the way in which we can write it. Okay, so all these identities, all these properties are really important for doing the questions in a following exercise. So you, okay, So now let us move on to our example number 21. Okay, the question is simplify. Okay, so we have to simplify or evaluate the following exponents given to us. So the first one is 2 raised to 2 by 3 into 2 raised to 1 by 3. So here if you see the bases are same and it is of the form. This dot is actually into. Okay, whenever you see a dot, it is not like point and all. This dot represents multiplication, that is 2 raised to 2 by 3 into 2 raised to 1 by 3. Okay, so here if you see, we can see our identity, that is a raised to m into a raised to n is equal to a raised to m plus n. Whenever multiplication is there and the bases are same, the powers get added. So I can write 2 raised to 2 by 3 plus 1 by 3. Okay, I am adding the powers. So how can I write this? 2 raised to, we know the denominators are same, 2 plus 1 it is 3, so I will get 3 by 3. So this 3 and this 3 cancel, so I will get the answer as 2 raised to 1. So 2 raised to 1 is what? 2 itself. Okay, so this is my answer. So here, what is the identity that we used? A raised to m into a raised to n is equal to a raised to m plus n. We just added the base and formed our final answer. Okay, I hope it is clear. Now, our second question is 3 raised to 1 by 5, the whole raised to 4. Okay, this is okay. This also we know. A raised to m, the whole raised to n is equal to a raised to mn. Okay, so I can write a raised to m, the whole raised to n is equal to a raised to m into n. So here I can write it as 3 raised to 1 by 5 into 4, which I can write 3 raised to 4 by 5. Okay, this is my answer, 3 raised to 4 by 5. Now, the third question is 7 raised to 1 by 5 divided by 7 raised to 1 by 3. Okay, so this is, okay, this also we can see something is dividing. So this is your identity, a raised to m divided by a raised to n. The bases are same. We know a raised to m by a raised to n is equal to a raised to m minus n. Okay, a raised to m minus n. So how can we write this as 7 raised to 1 by 5 minus 1 by 3. Okay. Now I hope you know how to do this. So how can we do this? 7 raised to, we just since the denominators are not same, we can do cross multiplication. So 3 minus 5, this 3 multiply here, 5 multiply over here, the whole divided by 15. Okay, so we know 3 minus 5 is what? 7 raised to minus 2 by 15. Okay, this is the way in which you can write it. 7 raised to minus 2 by 15. Okay, so our next question is 3 raised to 15 into 17 raised to 1 by 5. So here also we notice the identity that we have to use, a raised to m into b raised to m is equal to a into b the whole raised to m. If the bases are different but the powers are same, we can always multiply the bases. So here I can write it as 13 into 17 the whole raised to 1 by 5. We know 13 into 17 is what? 221. Okay, 221 the whole raised to 1 by 5. This is your final answer. Okay, so basically if we know all our identities, we can easily solve our questions. Okay, so now you can note it down. Okay, so now let us move on to our exercise number 1.6. Okay, here the every question is to evaluate each of the given exponents to you. Okay, so if you see the first question is 64 raised to 1 by 2. Okay, we have to simplify this. Now, whenever such thing, like whenever such big numbers are given to you, we should think that in which way we can write it in its power form. so that we can cancel out something. So if you see 64, we know 8 square is 64. Okay, we have to think before we are solving. Like, can we raise this given number to the power of something? So we know we can write 64 as 8 square. Okay, the whole raised to, what is left with you? 1 by 2. Okay, so I can write it like this. Okay, 64 I wrote it as 8 square, the whole raised to 1 by 2. Now we know a raised to m in the whole raised to n is equal to a raised to m into n. So how can I write this as a the whole raised to 2 into 1 by 2. So I will get over here 8 the whole raised to 2 by 2. This 2 and this 2 cancels. Finally we will get our answer as 8. Okay, I hope I am clear with it. So basically you should see how can I write this 64, how can I write this base so that my denominator present over here cancels off. Okay, that is the method in which we do such type of questions. Now see the second one also, 32 raised to 1 by 5. Here you see the denominator is 5. So definitely we have to write this 32 as something raised to 5. That is fixed. Because if we want to cancel this 5, we have to write this 32 as something raised to 5. Now what is that something? So we know 2 raised to 5. 2 raised to 5 is 32. So I can write this 32 as 2 raised to 5. If you don't know that 32 is 2 raised to 5, you can definitely do the factorization and see. So 2 raised to 5 we wrote, the whole raised to 1 by 5. Now see, here we can see clearly that this and this will definitely cancel off. That is the way in which we should write the base, so that this thing and this will cancel. So this is a raised to m into a raised to n is equal to a raised to m into n. So I can write it as 2 raised to 5 into 1 by 5. So I will get this as 2 raised to 5 by 5. 5 and 5 cancels. I will get my final answer as 2. Okay, I hope it is clear. Now the next one is 125 raised to 1 by 3. So here you see the denominator, it is 3. So we should know that we have to write it as something raised to 3. Okay, so we know 5 raised to 3 is 125. Okay, if you don't know, you can do factorization and see. So 5 cube the whole raised to 1 by 3. 5 cube is 125. So now you can see a raised to m into a raised to n identity. So I can write 5 raised to 3 into 1 by 3. So this 3 and this 3 cancels. 5 raised to 1, we know it is simply a 5. Okay, I hope I am clear. Okay, so now let us move on to our question number 2, the first one. So the first one is 9 raised to 3 by 2. So as I told you in the previous question, whenever we get something like this, always look at the denominator. Here the denominator is 2. So we have to definitely write the base as something raised to 2. Okay, so if you see over here, I can write this 9 as 3 square, isn't it? The whole raised to 3 by 2. Okay, now we know a raised to m, the whole raised to n is equal to a raised to mn. So I can write this as 3 square into 3 by 2. Okay, so here I will get 3 raised to 2 into 3, 6 by 2. We can cancel it off, so we will get it as 3 cube. We know 3 cube is what? 27. Okay, I hope I am clear. Always see that how can we write this base as power of something so that these two will cancel off. Okay, we can see these are cancelling off and we are getting our answer as 3 cube, which is 27. So now the second one is 32 raised to 2 by 5. Here the base is 5, so we have to write it as something raised to 5. So we know 2 raised to 5 is 32. So 2 raised to 5, the whole raised to 2 by 5. So we can just multiply, okay, we can just multiply it. So 2 raised to 5 into 2 by 5. So if you see this 5 and this 5 cancels, we will get it as 2 square, and final answer we will get it as 4. Okay, I hope I am clear. Now the next one is 16 raised to 3 by 4. So the denominator is 4. So we have to write something raised to 4. So we know 2 raised to 4 is what? 16. So 2 raised to 4, the whole raised to 3 by 4. So I can write it like this: a raised to m into the whole raised to a raised to m, the whole raised to n is equal to a raised to m into n. So I can write it as 2 raised to 4 into 3 by 4. This 4 and this 4 cancels. I will get the answer as 2 cube, which is equal to 8. Okay, I hope I am clear. Now the fourth one is 125 raised to minus 1 by 3. Now don't worry about this minus. We know 125, we know it is 5 cube. Okay, 5 cube is 125. The whole raised to minus 1 by 3. Again a raised to m, the whole raised to n. So I can write this as 5 cube into minus 1 by 3. So this 3 and this 3 cancels. We will get the final answer as 5 raised to minus 1. Now we have learned our identity, that is a raised to n is equal to 1 by a raised to minus n. Okay, so here we have to use this identity. So now here it is 5 raised to minus 1. If I want to bring this fellow to the denominator, I can write it as 1 by. Okay, 1 by. Here it is 5 raised to minus 1. When it goes to the denominator, the sign should change. So it should become 5 raised to positive 1. Okay, when something in the numerator goes to the denominator, the sign of the power will change. So I will get the answer as what? 1 by 5. Okay. So this is your answer. Whenever there is a negative, it goes to the denominator, it becomes positive. If it was plus 1 and it goes to the denominator, it would have become 1 by 5 raised to minus 1. Okay. I hope I am clear with all the questions in second one. Okay, so now let us move on to our third set of questions. The question is simplify the following. Okay, so the first one is 2 raised to 2 by 3 into 2 raised to 1 by 5. So here we can see our identity, a raised to m into a raised to n. You know our identity, a raised to m into a raised to n is equal to a raised to m plus n. Okay, this is our identity. So definitely we can write this as the bases are same. So you can write it as 2 raised to 2 by 3 plus 1 by 5. We are adding the powers. Okay, now you know how to do this. We can do our cross multiplication. So this we multiply with this. So we will get 10 plus 3 divided by 15. This into this plus this into this divided by the denominator. So here we will get 2 raised to 13. So here you will get 2 raised to 13 by 15. Okay, this is your answer. 2 raised to 13 by 15. Okay, now let us move on to our second question. Our second question is 1 by 3 cube the whole raised to 7. Okay, so here what we can do is just open this 7 and multiply this 7 with both numerator and denominator, because it is whole raised to 7. Whole raised to 7 means this 7 is applicable for this and this. We know a raised to m. Here we can write it as 1 raised to 1. So a raised to m, the whole raised to n is equal to a raised to m into n. We know that. So here we can write this as 1 raised to 7 divided by 3 cube into 7. Okay, I am opening this 7 and multiplying it on both numerator and denominator, because we know a raised to m, the whole raised to n is equal to a raised to m into n. Okay, so from here I will get, 1 raised to anything, it is 1 itself. 1 raised to 7, 1 raised to 10, 1 raised to 100, 1 raised to 1 crore. 1 raised to anything, it is 1 itself. So I will write here 1. So 3 raised to, I know 3 into 7 is what? 21. So I will get 1 by 3 raised to 21. Now if I want to bring this 3 raised to 21 to the numerator, what should I do? this we know 1 by a raised to n is equal to a raised to minus n. So if I bring this fellow to the numerator, the sign of the power will change. That it will become 3 raised to minus 21. Okay, this is your answer. Now, our third question is 11 raised to 1 by 2 divided by 11 raised to 1 by 4. This is of your form a raised to n by a raised to n. Okay, so we know a raised to n divided by a raised to n is equal to a raised to m minus n. Okay, this is our formula. So we can write 11 raised to 1 by 2 minus 1 by 4. This is m. Okay, this is m and this is n. So m minus n. So we can write this as 11 raised to, we can do the cross multiplication over here. So 4 minus 2 divided by 4 into 2 is 8. So from here I will get 4 minus 2 is what? 2. 2 by 8. So from here I will get it as 11 raised to 1 by 4. Okay, this is my answer. 11 raised to 1 by 4. Okay, so now let us move on to our fourth question. The fourth question is 7 raised to 1 by 2 into 8 raised to 1 by 2. So we know that the powers are same but the bases are different. If the powers are same and the bases are different, we can always multiply the bases. So we know a raised to n into b raised to n is equal to a into b the whole raised to n. So we can simply multiply it 7 into 8 the whole raised to 1 by 2. You know 7 8s are what? 56 the whole raised to 1 by 2. Okay, this is your final answer. Okay, so you can please note it down. Okay, so now we have completed our exercise number 1.6. I hope all the questions that we did today are clear to you. So now let us meet in our next video with a new topic. Till then, thank you. Please like, share and subscribe the channel.